right, folks. Cool. Apologies for the delay. Just had a little technical issue getting set up. We're up and running now, and we're ready to go. Cool. So please feel free to post your questions in the thread under the message in study hall. If I already got something. Oh, it just says, thanks, Clark. The study hall is really helpful. Looking forward to this one. Yeah, you're welcome. I hope they are helpful. Cool. We already got a question posted in. Let's go. Oops. And I can't click on things. Can I click on things? Okay, good. Now I can click on things. Here we go. I feel like this is like messy. Let me clean this up a little bit. There we go. That should be a little nicer. Get a nice clean slate here. All right. Q3 of 5 board members. I apologize. I'm actually going to have to forgo this question. I've tried to go through this on stream, and it takes up this particular question before. It takes up a lot of time. Apologies for that. So DM this to me, and we'll work on a solution outside of stream for this one. Apologies. Oops. Here we go. I'm going to pick up with where we left off with the list functions on the pop method. Yeah, sorry about this question in particular. This is a kind of a bigger one. So, okay. So before we were going through just list functions and methods, and we had left off on pop in particular. Cool. Oh, excuse me, we've got another question actually here. My bad. All right, binomial distribution. Which question are we going through? Okay. For now, I'm gonna constrain the questions to take on stream to the Python materials. I am just gonna say for now that I don't want to go through the stats materials yet on stream, if that's all right. Apologies, I know that's a bit inconvenient, but I think we're gonna open that up in the future. I could have made that clearer. Apologies to the person asking the question. Okay, cool. Thanks for understanding. Appreciate it. Okay, I'm going to pick it up with pop. We'll just get through this, and I'll look for more questions in a second here. Okay, so pop is a method that is built into lists. So what does that mean? We have lists recently. If you've if you've been in premium prep, we've been going through lists and talking about what they are, how they work, how to apply them, what they're useful for. And we've introduced the idea with lists, we've introduced the idea of methods. So let's just have a list here for 3, 7, I don't know. And the method that we looked at in premium prep the other day was list.append. And this will allow us to append, which just means to add to the end of, to append. Let's just say, I don't know, something conspicuous, hello. And we'll say print list, that way we can actually see it. We'll run the code. And of course I have to actually execute the code or the command for it to run. Okay, so we have 4, 3, 7, and hello. So you can see I initialized the list with these contents, and I added hello to it, and now our list reflects that. Pop, we'll be getting into this eventually in the premium prep materials, but pop actually sort of does something a bit opposite of append. It will remove a value and it returns it, right? So we've talked about like what it means for a function to return a value. Methods can also return values, but they often also don't return values. So in this case, right, if I printed out the value of appending to a list, you might think, well, the value of appending to a list, the value of this operation, the value returned by this operation is the list with the item appended to it. And that's not quite what happens. It's kind of a way of thinking about it, but it's not literally what's happening. So if I print out the value of appending to a list, the value of that is none, right? That means the append operation didn't return anything. All this does is it performs an operation that changes the list itself. So I can print that out and I'm going to get none, but if I run it again, if I print it out, we can see the result of, or the returned value from the append is none, but the effect it had on the list is that it still did the append, right? So there's sort of a difference between methods that cause a mutation and methods that return a value. Pop does both. Pop performs a mutation on the list and it returns a value. So let's look at that. So look, we can say list.pop, pop, list.pop. So pop takes an argument that's going to be the index of the thing that I want to pop. If I don't pass it an argument, it's going to pop off the last item. So I can say pop, and this is sort of a reverse append, because it, instead of adding an item to the end, it just removes whatever the last item is. So let's do this. Okay, so let's see what happens here. Let me get rid of this append print here, because I think that's clear that the result or the value returned by append, or append doesn't return a value, right? So we'll just do the append there. Then we'll print the list to see what it was like after append, and then we'll call pop on the list, which will remove the thing we just appended. And we can see our list has hello appended to it, and then after we pop, it lost that hello. But I can capture, now if I print this out, I can print out the pop, and pop will return a value. So you see pop will return that hello, and I can actually capture that value in a variable. I can say var equals, let's call it res for result, res equals list.pop, Okay, cool. 437 hello, and 437 forgot to print res. So the result is hello and 437. Cool. We can also specify a specific index to be popped. So let's say I wanted to pop the first element. I could specify index 0 and it'll pop the element at index 0, right? So pop will remove an element if a specific element anywhere in the list. It'll remove that element and return it anywhere in the list, provided that you know the index of the element that you want to return, or that you want to pop off. So that's something to remember. Pop returns and causes a mutation, and it removes the element at the index that you supply it as an argument. So this is the index. We supply that index 0 as the argument to pop, and we'll remove the element at index 0. Okay, cool. Let's kind of skim through this and do the challenges and see what we can do. SumList.pop. Let's see here. Okay. I'm not seeing too much here that I didn't cover, so I think we're good. Let's just do the challenges. Okay, given the following code below, what would print to the console? Random list equals true, 1, 5.5, and 3. Popped value equals random list dot pop. And then we print random list. So that's going to give us this. And we'll just cap that off. Cool. So we have our random list. We call pop on it. We capture the thing it pops off, which is going to be 3. Since we didn't supply an argument to pop, it's just going to pop off the last element. We're going to capture that. We're not going to do anything with popped value in this little snippet, but when we print off the list after we call pop on it, so it's just going to have that last element removed. So what happens here? Presumably this is going to be the same thing. This is going to be 3. Okay, so this is the same code essentially, except instead we're just capturing the value from pop and printing that off. So that'll be 3. Okay. I'm just going to copy this straight in. Have I done this one? Looks like I have done this one. Where is all my code? Oh, there it is. Wow. I have like a ton of solutions for this. I think I went over this on a stream a while ago. Let's just do it again though. Why not? Oops. Okay. Copy that again. And put that in there. Okay, it's common in mathematics to need to remove outliers from a data set. The pop method, in conjunction with the index method, can be useful in combination for accomplishing this task. Complete the remove outliers function. Okay, we even have a test for it. What's this going to take in? List, return, out. I don't know. I don't know if we're returning the list that we're taking in and causing a mutation to it or what. We'll see. the function below. This function should take one parameter called data. Oops, let's call that data. And is a collection called data. Let's say that is a collection of observed data. This function should return the data list with the smallest value removed and the largest value removed. Okay. Do not modify the original list. Make a copy first. Good. Data, and then let's just call this list. List equals data dot copy. There's a few ways we can do this. And then we'll say we want to return list. So I think what I want to do is I want to list, I want to do this for the min and the max. So I'll say list dot pop list dot index of, oops, let's get a little space in here. Okay, so we're going to pop from the list the index from this list of the min of the list and the max of the list. Cool. Okay, so we'll pop the index at the index of the max, and we'll pop at the index of the min. Return list. Of course, I forgot to print this out. Let's do that so we can actually see what our function is doing. And we expect this call to return, oops. I'm just going to give us some space here, just so we have a little visual relief. Okay. Now we can kind of see easier where things are going. So we have this list. Let's do this. My list equals the list, and we'll pass in my list. Into our function that we wrote, and we'll pass that function into print, and we expect for this list, we expect 55, 23, 68, 81, and 99. Let's see what happens. We're getting some output from up here. Excuse me, let me just delete that. Comment it out, I mean. Okay, so we got 55, 23, 68, 81, 99. And we expect 55, 23, 68, 81, 99. Good. So that looks like that's going to work. So let's just submit this and make sure it does work. Looks like I got all these. Oh, we'll just do this. Oh, this looks like exactly the same solution that I had before. That I just made. Just a different version of it. Cool. Alright. That'll work. I feel like there's some other ways to do this, but that's fine. Cool. Sort and reverse. Let's just copy or comment this out real quick, and we'll move on to sort and reverse. Cool. So apply the sort method and the reverse method. Okay, so this says, so far you've seen the sorted and reversed functions. However, we're going to start working with lists. There are two methods available to accomplish the same tasks, sort and reverse. So my preference over the sort and reverse methods are to use the sorted and reversed functions. Or my preference for teaching is definitely to sort of emphasize these more, because these are simpler tools with, I think, more predictable results. I think they're easier to use. So I'm gonna kind of go through this and kind of juxtapose sorted and reversed versus sort and reverse. Okay. So let's get some data to play around with. We'll just do this. My list equals the list, and we'll print sorted my list. Cool. So you can see we went from having 55 and not 1, which is less than 55, and 23, which is greater than 1. And so the elements are out of sorted order. And if we use the sorted function, the function version, it's going to give us back the list in a sorted form. If we print our list after we sort it, after we call sorted on it, we'll say my list, print that off. We're going to see that we have our original list. So sorted just got a version of our list. It got a version of this list that was sorted, and it returns it, right? But it doesn't alter the list. This is different than my list dot sort. Let's just do this real quick. Let's come back to that 1 second here. I just want to show this in a slightly different way. So we'll say my list equals the list, and then we'll say sorted list equals sorted my list, and then we'll print off sorted list here. Right, and I just want to show it this way to show you, like, this is sort of a de facto copy, right? We have our original list. Actually, let's just call it that. Origin list. Origin list and sorted list. So this is going to give us two different lists without altering the initial one. The dot sort method will alter the original list. It'll give us a sorted version, and that's it. Okay, so let's just prove this a little bit. We'll say we'll print out the list value followed by its ID, which will be ID of the list. Oh, shoot. There we go. That should probably do. Yeah, that'll be fine. Okay, so notice we print out the sorted list first, and then the original list. You can see their values and IDs are both different from the sorted and the original list. Then we call .sort on the original list, and then you can see it gives us the same sorted value as that first run, but the ID is actually the same as the previous line that was run, or printed out, I mean, where original list was not sorted. Cool. So this is useful if you're certain that you don't mind getting rid of that original starting list. Quick note on this: the origin list dot sort does not return anything. Like append dot sort is a mutable method. It causes a change in the value, but it does not return anything. So if you try to use this as in place as a sorted version of the list, you're going to be disappointed. Cool. Okay. Let's talk about reversing. So there is a function called reversed. Let's say let's do the same sort of thing that we did up here. We'll have our original list, and let's just call dot reversed on it right out of the gate. We'll do this in a little bit of a different order. We'll say original list dot reverse. Okay. Cool. So we have 55, 1, and 23 at the beginning here, and then we have those numbers reversed at the end on the second line that was run, that was printed out. So you can see this just reverses the order. This is, again, this is a mutable method. If I try to get the value of what the result of this calling reverse on the list is, if I try to print that off, we're going to see that reverse gives us none again. So this is another mutable method. It changes the list in place by reversing it. Now reverse is not, it's not so much of a permanent change, because if you want your original list in the original order back, you can always just call reverse again. So this isn't like, you're not as locked into the change, although I'd imagine it'd be fairly expensive, constantly doing that reverse operation on the list if you did it a bunch, but probably not that big of a deal. Sort of a small deal sort of thing. What I tend to do if I want to reverse a list, what I prefer to do is actually slicing. We've talked about this in Premium Prep recently. Colon, -1, right? So with this, with your slice, you have a start value, and then a stop value, and then you have your step value, right? Your step is going to define how many, the interval to slice the original list that you're trying to slice, right? So if I leave this blank, by default it's going to be steps of +1, like we're going to get one element and then the element next to that and the element after that and the element after that. If I say steps of -1, it's going to go in reverse. It's going to go backwards. So it's going to get the first element, then it's going to go the element before that, the element before that, the element before that. And it'll actually start at the end with the last element first and just go that way. So this is an effective reverse. Let's just do that. So I'll print out the reverse. Oops. We'll do that. Okay. That'll give us some context. Okay, so this reverse evaluates, this way of reversing something evaluates to the list being reversed, again without changing the list. So it's like it returns the list in reverse. If I print out the original list again, we'll see that it's not reversed. Cool, let's try that out. Good. Okay, so we have our original list with nothing done to it. We have our temporary reverse, which gives us back a reversed version of the list temporarily without altering the list. And then we have our original list again without needing to do anything to it. So our list didn't change. This just gives us a backwards version of it. Yeah. There's another way to do this. Let's just comment some of these out here. I'll just take this out of the print. We don't need to do that. Just trying to clear things up a little bit here. And I'll just comment those out for now. Okay. So there's another way, oops, to reverse something. There is a function. So what we looked at is the slicing approach, the method, and there's also a function. We've talked about this in previous study halls. If you're at this point in the material, you've already seen this. There is the reversed function, VERSED. This one is weird because, oops, I lost my terminals. Huh. There we go. Okay, let's try that again. We'll run it. We're going to get this list reverse iterator object and a reference to the location where this resides. So this isn't quite probably what you expect, right? It's just a reverse iterator object, and it's kind of a weird one. This can be cast as a list though, which is great. This is really useful. The reason you don't get a list in return with this one is that this is optimized for passing to for loops and being able to iterate through a list with a generator. That way, you know, imagine I had 1 million records in this list, or 1 million elements. If I did this way up here, right, I'm actually going to duplicate, I'm actually going to get a reversed version of the list back that's its own independent version of that original list. So I'm actually duplicating those records in my program's memory. In small cases, this is fine. It works just fine. It's not a big deal. If you have 1 million records, then that could potentially be a lot of extra overhead. Or it doesn't have to be 1 million, you know, but just if you have a significantly large data set or something, you might not want to just arbitrarily duplicate it. So reversed just iterates over provides a reversed iterator over the list, where it iterates over the list from end to beginning rather than from beginning to end. So it's just a little time and efficiency saver for loops specifically, and that's why it is the way it is. Cool. All right. So that's that. Let's just go through these challenges, and I do see we have a couple questions in Slack. I will jump into those in a second. What's the main difference between, or what's the main, what? What is the main difference the programmer needs to be aware of when working with sort and reverse methods compared to sorted and reversed? I'm just going to say mutable. No, I'm not even change. Okay, I'll read them. Fine. Sorted and reversed functions sort and reverse the list in place, whereas sort and reversed return, it's the other way around. It's this except opposite. So the sorted and reversed functions return the list that is sorted and a new list that is reversed kind of, and reversed returns a generator, as we just saw. Whereas sort and reverse return a new list sorted in place. This one says there's no difference. Let's see if this one says the thing about the reverse iterator. It looks like it does. So the sorted function returns a new list that is sorted. The reversed function returns an iterator object of the original list in reverse order. Yeah, that's correct. The sort and reverse functions, the sort and reversed methods sort and reverse the list in place, changing its value. That's the one. Good. Complete the function. Did I complete this one? Looks like I did. Let's just cut this. Almost hit Control Q by accident. That's great. Just quit the browser midstream. Why not? Glad it didn't commit to that. All right. So let's just look at this. We'll reset the input. Let's have this here, and I'll grab this copy. Okay. Complete the function named sort and test. This function will take two parameters, both of which will be lists. Your function should sort the first argument without altering the original list. So we'll copy and sort the copy and then compare the sorted list to the second argument. If your function will return a Boolean value, which is a result of comparison, true or false. Okay, note, we have included a doc string for this function that describes what the function is doing, as well as each parameter. Good. So this will be a reference if we need it. So we're just going to sort list 1. So we'll say list, let's call it list 3 equals list1.copy. So we'll copy it, and then we'll list, oops, I should be consistent. That's a little ugly looking. We'll use list, list3.sort, and then we'll return list3 equal to list2. Let's try that out. Oh, let's print the result. True. Oh, did I actually have, let's do these down here. That's confusing. That's different than I usually lay out my code here. All right. So we've got our function definition. We've got our doc string. We've got our data down here, and we'll pass it into our function. True. So it says evidently sorted x is equal to list in this range. So let's just try to submit this and see if I can get it to pass. We'll just reset the input. Looks good. All right, complete the function below. Please follow the description in the docstring. Good. So let's do this one. So it says reverses the input list in place. Removes the last element of the now reversed list and returns that element. Okay, so that's just going to be the, oh, looks like I copied in my solution. I thought this was empty. I'll pretend like I didn't see that. So this is actually just going to return the first element, right? So it's going to make the first element last and last element first. So we'll say yeah, okay. We'll say list one dot reversed. And then we'll say list one. We'll just return actually. List one dot pop. We'll just pop the last element. Oops, I said reversed because I'm just kind of used to using reversed. We'll use reverse here. Use the right element or the right method name. Cool, let's print result. -10, is that what we expected? I don't know. Seems rational enough. Yeah, that's actually the code that I had anyways. Okay, good. I want to say that there's another way that I could solve this that's kind of cheaty. But I'm just curious if I can get this to pass, if I can make this work for the wrong reasons, just because, I don't know, because that's fun too. So we just have to end up with the list reversed. I guess the easiest way to do that is reversed. We could return list dot or just list sub 0. That would be what we pop. Although I don't think that's gonna, I think it's gonna also test this list because we're mutating it globally. Yeah, so that's not gonna work. Shoot, I thought I had a sneaky way of solving this, but it's less sneaky than I thought. I might be able to get away with okay, I'll just follow this out. Rev list equals list one colon -1 dot copy. Oh no, that'll be a de facto copy actually because I'm doing a slice. And then we'll say list list1 dot clear list1 equals rev list. No, it's dot extend. I think that'll do it. If not, I'm just gonna move on. Now I really want to do it. I already said I would move on. List is not defined. I don't think I'm moving on. That's right. We'll do this. Oh, rev list sub -1. Okay, that wasn't as fun as I thought it would be, but still kind of interesting. Let's just see. I think that'll work. Yeah, that works. Okay. A ridiculous alternative, because why not? Good. I'm going to come and look at this code again someday. I'm going to be coming through here and see, oh, it looks like I had a previous solution to this, and I'll look at this and I'll be like, who wrote this code? This is insane. This is a ridiculous way to solve this problem. But that's probably what's going to happen. That's fine. It's like a practical joke I'm playing on myself. Okay, cool. Sorry to keep y'all waiting. Let's go through some questions here. Remove a dictionary. Removing dictionary keys and values. Okay. So this is def delete dups. Let's just search for that. That's number 3. Okay. I'm going to copy in the code supplied by the asker. Okay. Here's the code. Let's look at the copy. Okay, write a function called delete dups. This function should take a dictionary as an argument. This function should go through the values inside the dictionary and remove any key value pairs where the value occurs more than once inside the dictionary. Okay, let's pair this with a test right away. I'm just going to do that. Right off the bat, I do see a problem with this code. I see an imminent return in the for loop. So before I even get into diagnosing what's going on here, this is definitely a problem, and it might be the only problem. It might be the case that if I just move this back, if I tab that back to the left one level, that might fix it. Sometimes that'll do it. But what's happening here is we have this for loop. We're going to loop through the dictionary, the items of the dictionary for key value in the dictionary. And then we check a condition, and if the condition is true, we delete some key from the dictionary. And then at the end of this first iteration, we return. When your function encounters a return that it runs, when it like encounters a return line that it executes, it is no longer going to execute any code. So it's going to return dict2 whether or not this was true or false. It's just going to move on and return dict2, and it's not going to go to the second iteration. It's not going to do any more code execution. So there are times where you have a return inside of a loop, but I think it's safe to say that it's under all circumstances that I'm aware of, that return is going to be under a condition. So it's more like you have a return inside of a condition inside of a loop. So there's certain functions where you can write that you can write where you go through and you go through some collection or a range of things, and you're checking a condition, and it might be such that if you see a certain condition, if a certain condition is met, you can just stop all the iteration and say, oh, we found our condition. If this condition is true, I know exactly what to return, or I know exactly how to determine the return. So we'll just return underneath the condition, meaning underneath meaning inside the condition, right? So we'll just put a return inside the if or the else or whatever, and then that might prematurely stop the for loop, but it's not going to stop it every time, and it's not going to stop it after the first iteration every single time. Since this return is nested, since it's tabbed in past the level of the for loop, it's considered to be inside this for loop, so it's going to run as the last action of the loop. Cool. Sorry if I kind of hammered that a lot, but I just wanted to make sure that that was clear. I wanted to make sure it was clear because I've had a number of people make this exact mistake recently, and I think it just deserves a little extra airtime. All right, so we're deleting duplicates. And I was going to make a test. Let's do that. I'll print this with D. We'll just make a dictionary real quick. So D equals a dictionary. And in our dictionary, we will have A, 5, and I think, let's see here. This function should go through the values inside the dictionary, the values inside the dictionary. I see. The values in the dictionary and remove any key value pairs where the value occurs more than once in the dictionary. Cool. So I see the code. So I do see another problem with the code here. We say if the length of the value, presumably what this means is if the, I think what the intention of this line is seems clear to me, that it's saying if the number of times the value occurred in the dictionary is greater than 2, then we know it's duplicated. And if that's true, then we're going to delete it, right? And I actually see a third problem, which is that we are looping through the dictionary as we're removing elements from it, and that'll give us another issue as well. So let's do this. I'll get to those right after I make a test. Okay, so we'll say B also equals 5, C equals 6, D equals 4, E equals 6 again, and I'm just having a few things here. F equals 9. Okay, so we have A and B are duplicated, so C and E are duplicated, so we should just end up with D and F after this is done. So our expectation is going to be D and F. Oops. Oops. Okay. I'll stop messing around now. Okay, there we go. So this is what we expect to have returned. Okay, let's just see what it does. Type objects. Or a type error. It says object of type int has no len. Right, so again, I believe I understand the intention of this line, where the intent of len is to count how many times this value occurs. When you're doing a count, which you can do, there's an operation that's very similar. There's an operation that'll do this. It's called count. So if I say, I'm just going to do this. I'm going to say values. I'll call it vals equals dict 1 dot values, and we'll just cast that as a list right out of the gate. List like that. Cool. So there is an issue. So we took in dictionary 1, we copied dictionary 1 and saved the copy in dictionary 2. There is an issue here in that we are looping through dictionary 2 and mutating dictionary 2 with this delete. Delete is causing a change in dictionary 2, specifically a change in the size. So that's going to cause a conflict with how, with Python's ability to loop through the dictionary. So, okay. Let's just run this real quick. Vowels, right? I kind of got off track there. Okay, sorry. So replacing len, we can use vowels.count value. Okay, so if the count of value in vowels is greater than 2, then we can delete. So what count does, and you know what? It just occurred to me, I might be able to do this right here. Do dict1.values right there. I think that'll work. Yeah, okay, so that's kind of what I was thinking initially, is that dict values object has no attribute count. So count isn't built into dict values like that, but it is built into lists. Okay, so we'll use the list method count. So we get this list of the dictionary values, and then we look in that list called vowels, and we count the value. Value is for key value in dict2.items, and then if vowels.count value is greater than 2, then we remove it. Okay. Oh my gosh, is that working? Doesn't appear to be working. That's interesting. Let's print this. So sometimes you end up writing a condition that doesn't run. Oh, this condition isn't running, right? So check it out. What's the first number that's greater than 2? 3, right? A has a value of 5. 5 occurs as a value twice. So what we need to do here is greater than or equal to. And that should fix it, but it should give us an error here. So this says runtime error. It says dictionary changed size during iteration. So while we were iterating through this dictionary, we changed its size, right? So we have, in scope here, we have 2 copies of this same dictionary, so that makes it pretty easy. We'll do the delete on the copy. That way we don't change the original, and we'll loop through the original like this. So D4 and F9. What did I expect? D4 and F9. That looks good. Cool. So just to recap here, let's compare this code with the code I was originally sent. Okay, so I think there were 3 things. Yeah, so there's the return, the imminent return of, or the, excuse me, imperative imminent return. God, oh, God, I'm such a nerd. An imperative return. This return is an imperative. It's going to happen every time. So the return inside the loop, we needed to fix that. we needed to fix this. The idea here is good. We needed to fix that and change it to count. We needed to check inclusively, so that's 3 things. And then we needed to loop through a different object than the one we were mutating. So that's four things. I'd say probably this one, we needed to create vowels as well. Although this is kind of trivial. I'm not counting that because, you know, like the idea is there. And we could do that in there, right? We do list of dict1.vowels. But I didn't want to recreate this list every single time we ran this this code here. So this will run this list dictVowels function and method every single time. We don't need to do that. We can just do it once before the loop starts, and I don't know, just a small optimization. So you know, that's what 4.5 changes that I made. Cool. I don't want it to be like too like I don't want it to come off too critical. I like the way that you were thinking about the solution to this. You're on a good track, just kind of had a few kinks to iron out, which is all right. Okay. Okay. So we have a request to go through the self-placement challenges. We need to be. I need to start including this in the in like the notes for study halls. I talked about this with my team, and we decided we're not going to do. We're not going to go through the self-placement challenge questions in study hall because it kind of defeats the purpose. I think we're going to stop like helping people with those because the purpose of the self-placements is to give you an idea of where you're at so that you know where to start in our material, right? It's there to say, well, if you got to this point, then we recommend that you start in this place in our material. So it's there to give you an idea of where you're at relative to the material that we have, or if you're ready for the technical interview. So if I help you with those, it defeats the purpose of them a little bit. So apologies for that. Cool. Let's see here. Maybe there's another one in here. Try to remove has 3 arguments. Test key. Or test dict, test key. Pop. Okay. Maybe we'll just do this one real quick. Oh yeah, just put this down at the bottom here. Cool. Thank you for understanding, by the way. Appreciate it. All right. So I'll just do this other dictionary remove problem while I'm here. Kind of like these. Oh, come on. Okay. So write a function called try to remove. Okay, so I have my definition and my call, and we'll just kind of start filling it out as we go. It takes 3 arguments. Good. There we go. So we'll tab this in. We'll say test dict, test key, and pop. And we'll just pop these here. There we go. Here's our 3 arguments. The first one's a dictionary. I'm just going to recycle my old dictionary from the previous question. Put that here, pass it in for D. Test key, which is presumably, I think this is going to be a key to see if it's in there. Let's just read this. So a key that may or may not be in the dictionary. So we've got a may or a may not. So let's do 2 tests. We'll duplicate this. And let's do a key that is in there and a key that's not in there. So a key that is in there is A, and a key that's not in there is G. Let's be real clear, and let's say Z. So A is in there and Z is not. And then pop, a parameter named pop whose default argument is true. So we want a default for pop. Pop is at the end, so we can default it. We can say equals true. Good. Okay. So the function should check to see if test key is in test dict. If it is and pop is true, the function should pop the value of the input dictionary and return it. Okay. If the key is in the dictionary and pop is false, the function should simply remove that key value pair from the dictionary and not return it, I guess. If the key is not in the dictionary, function should return the string key not found. Okay, so this is sort of our final case, or our edge case rather. So I can just say, I'm just going to handle this edge case right out of the gate. I'll say if test key is not a member, so I'll do a check for membership. I'll say if test key not in test dict dot values return key not found. So I already have a test for that. Z is not in the dictionary, so we can do key not found. Okay. So in this case, both of these cases, pop is true because I'm not supplying an argument, so it's going to use its default. Let's just duplicate both of these, and we'll pass false. So this one should still say key not found. I think this one should literally not return anything from what I've read up there. I'm just going to write it that way for now, and if it fails when I submit it, then we'll handle it at that point. All right. Cool. Test key not in test tick.values, return that. I guess I can do elif. Not that it matters. I'm going to do if. We'll do if. If so actually at this point we know test key is in dict, so I don't need to test if it's in the dictionary. So I think I can just say if pop. Right? Now you might think, well, I would need to do if pop equals true. Right? But remember, a condition is just any expression that evaluates to true or false, including true or false, right? So pop evaluates to true, or false if I give it false, right? So I don't need to see if it's equal to true, I just need to say if pop, and since its value is either true or false itself, that is a sufficient condition here. So we'll say if pop return test dict dot pop test key. And actually what I'm going to do here is res. We'll save this in a variable called res for results. So we'll say res equals test dict.pop test key, and then we'll say if pop return res. And I think that's it. There is a case where we're not going to get anything returned, so this should be 5. Let's see. Oh, we got key not found every single time. Huh, okay. Well, that's a little broken. So if test key, let's just print this off. Print test key. Gosh, what did I miss? Should get AZ. Yep, AZ. Oops. Come on. AZ. So why is it not found? Oh, I'm doing dot values. I should be doing dot keys. That's just me being silly. I was checking if it was a member of the values. I need to check if it's the member of the keys. That's just brain fart. Okay, try that again. So 5 and then key not found. And then looks like we get key not found again here. That's really interesting. That's very interesting. So let's say print test key. That doesn't make any sense to me because A is in the dictionary. Oh, of course. A is not in the dictionary, right? This is why this is why you don't write functions that mutate their inputs. That's something I forgot to mention. This is not a good pattern to use for functions. The reason is it takes in a dictionary and it causes a change in that dictionary. And I remember when I started this function, I was like, okay, we've got a function that's mutating its input. Like, okay, I'll just solve it in the way that they're expecting here. Let's see. And I think it's specifically asking for that it alters the global variable passed to it. The function should check if the key is in the dictionary. If it is and pop is true, the function should pop the value and return it. If the test key is in the dictionary, Okay, so it sounds like it does want me to mutate it. What I would really, this is a perfect case for copy, and I would rather write this with copy. I would say test dict equals test dict dot copy, and then that's actually going to give me the behavior that I expect. So this one should give me none, right? The reason that this is happening in the way that it is without that copy is this first function literally changes the dictionary that we pass to it, which is what I'm trying to say is the thing here that is not good. That's what I'm saying is not good. Okay, so we don't want to write functions that cause changes to their inputs. So this function does. That's what learn is asking for. I wish it wasn't, but it is, apparently. we'll see that. We'll test that hypothesis, actually. Maybe I'm just reading it wrong. So if I print this out, notice we have the key of A in the dictionary up here. Then we call the function, we pass it D. The function alters D by removing A. And then if you look here, we print out D and A is missing, right? So that caused a change. And then in this case down here, I'm checking for A and I'm expecting it to be in the dictionary, but it's not, because that's what happened. So what I need to do if I'm going to be writing a mutable function is I need to reset the input every single time. It's kind of annoying. Kind of takes up a lot of space. Makes testing difficult, but that's how it is. Cool, so let's see what our output is. Okay, 5, key not found, none, and key not found. And we expect 5, key not found. I should put none here. None, and key not found. Good. Okay. I'm going to submit this. We'll see if Learn thinks this is a working solution. And if not, we'll figure out why. Okay, so this is a working solution. And it does alter its input. I'm going to try it with testdict equals testdict.copy. I think I'm going to bring this problem to my team and just say, like, hey, I think we need to change this problem to explicitly ask people to copy. Of course, that's happening in the next lesson anyways, so maybe it's okay. Cool. Let's see what I had. I had a solution for this before. We'll just see. It's probably exactly the same, but maybe not. I don't know. So if key in dictionary.keys and pop. Oh, this is actually a pretty different solution. Wow, this is like totally different. Huh. So if the key is in the dictionary and pop is true, then we return pop. Elif key in D keys and not pop, then we pop and then just return. Otherwise, if none of those two things are true, then we just return false. This doesn't seem like code I wrote. Maybe I did write it. That's seems like perhaps someone else's solution. Maybe I was helping somebody with that and I helped them submit their solution or something. All right. Cool. Okay, let's see. Where were we here? All right, I'm not seeing any other questions. Apologies about the limits on the questions that I'm, like the limits on the places that I'm taking questions from. I think, I'll own that, and I could, we could do a little better about communicating where we're going to take questions from, the parts of Learn that we're going to take questions from. Yeah, apologies for that, for any inconvenience about that. But yeah, if you have any other questions from the Python material, I'll be happy to go over those. Okay, cool. So it looks like we got through sort and reversed. Let's move on to something else. Okay, count specific items. Cool, we just kind of did this one. We had an example of count earlier in stream with this question. We were looking through the dictionary and we're counting the values in that list that we made. So that gives you some idea of count. But let's look at this. So the general syntax is we have some list. We call count on the list, and we pass some item to count in the list. Let's play around with that for a little bit. Oh, come on. Basic computer usage skills happening right now. Okay. Okay, so we have our list. We'll just have some items to count. So we'll have 4 and 5 and 5 and 6 and 5 and 7. Okay, so there's some 5s. There's some 7s. We're good. So if I say print, so count is a method, but it's not a mutable method. It is a it's a method that returns a value. So if I say list dot count, let's do this. 3, 4, 5, 6, 7. Okay, so we have no 3s. So we have no 3s. We have 1 4. We have 3 5s. We have 1 6, and we have 2 7s. So we should see 0 1 3 1 2. Zero, 1, 3, 1, 2. Good. So we have to have a thing that we want to count. If that item doesn't show up in the list, obviously the count of it is 0. And then we have to have a pool to count from. So that's the two things you need. You need a source to count from and a target to count. Yeah, let's just do the challenges. So what will count of items, what will the value, oh wait, excuse me, what value will count of items have after the code block, after this code block is run? Gosh, being extra dyslexic at the moment, apologies. So we have our list, our value defined is going to be 1. So we say list count value defined, count of items is going to equal the count of 1s in our list, which is 1, 2, 3, 4, looks like, if I did my counting right. Cool. Write a function called, oops, I'll just clear that out for now. Okay. Let's just do this real quick, and we'll reset our input. Oops. Write a function called sample percent. Let's do that. So sample percent, looks like we have an example here. Oops. Gosh, all right. So let's just do our example. So our expected result here, I'll just move that there, and then we'll just print this. Okay, cool. So here's our input list, here's our sample percent, da-da-da. Okay. Okay. Let's just see. Write a function called sample percent that takes 4 parameters. Wow. Okay. The first parameter, obj list, will be a list of the observations. The second, third, and fourth parameter is called group 1, group 2, and group 3. Let's just pop those into our definition. Delete that and. Our objects whose counts should be recorded. The function should return a list where each item is a percentage of the count of its respective group relative to the total number of elements in the obj list. Okay. So it's the amount of space that that element takes up. Okay. So dog is the first argument. It takes up 0.5% of the elements in the list. So 50% of the elements are in the list are dog. Cat takes up 25% because it's 1 out of 4. Fish takes up 25%. We're not testing for fish. Oh, wait, are we? Yeah, of course we are. Yeah. So those take up 25% each. Did I say 24? I feel like I said 24. Why would I say that? I don't know. Too many questions. Okay. So let's just kind of return that list. It's going to be a list of we'll just call it space. We'll just call it space. 1 space 2 space 3 equals 0. Can I do that? Can I initialize all of those as 0 if I print those off? I don't need to print those off. I can just run it and it'll return. Oh, okay. What was the first one? What did they want us to call the first one? Obj list. Obs list. Okay, there we go. Okay. That's how you do it. Cool. Okay. So, I think space 1 should probably equal, might be able to get rid of this line, should equal, well, let's do the len. I know it's going to have to do with the len of obs list. Is it the len over the count? Yeah, it's going to be over the obs list dot count group 1. Yeah, that should do it. So let's just see if space 1 is going to be correct, and if it is, we'll just run those down for the other ones. Group 1 is not defined. Of course, they probably just misspelled it. Goerp or something. I don't know. I just didn't spell it. Gorup. Maybe the other way around. Dog. How did I get 2.0? Huh. Okay. Print len obs list. Am I like... Okay, 4. Oh my gosh. Oh my gosh. Right. Because 4 divided by 2 actually is 2, right? Yeah, okay. That makes sense. So what would I do? I think I would just do 1 over this. Is that going to give me the right thing? Yeah, of course that's going to give me the right thing. I forgot the 1 over part. Okay, so we'll do 2 and 2, and then we'll do 3. Cool. So I don't need to initialize like this anymore. And I can just do this. I guess technically I could also, as an alternative solution, I could be, this would be an insane and difficult way of doing this problem. Cool, now we have a one-line solution. Isn't that nice and elegant? Cool. So that does work, but it is a beast. If you were going to go for a one-line solution like this, give it a little space. Let's do this. A little bit of regularity, a little bit of space. Make it much easier to read and deal with. There we go. That's much nicer. So this is fine as well. We're just doing these calculations right in place in the list, but this is fine too. And I think, honestly, I still think this actually reads better. It's very clear, easy to deal with. Let's run that. I think the second one was my solution from before. Oh, no, not at all. Again. This is definitely me code. That's interesting. Or at least I formatted it. That's the way I format something. So let's look at this other way that I solved it. Looks like I just had a list and, oh yeah, because that really makes sense. I just did for I in group 1, group 2, and group 3, so I just iterated through this tuple and I appended the count of I over the len of the, oh gosh, that's so much, right, the other way around. I did it the other way around. That makes more sense. This makes way more sense. Okay, cool. Well, perhaps my lesson for today is to get more sleep or something. I don't know why I didn't think about doing it this way. Laying it out in reverse order so I don't have to do like 1 over all that other stuff, but cool. Oh, look, this doesn't even work. Okay. That is interesting. And I bet it is because I'm doing this in a ridiculous way here. So let's actually just do I should just do this up here. Do this the right way. Let's do this the right way. Let's try that. Uh-oh. And then we'll do the same for this. Mix that solution out too. That should work. Okay, let's make sure we get the same result here. Cool. Cool. Good. All right, that'll work. Cool. One more. Let's do one more. I actually really want to keep this one because this is actually a good solution. A few solutions for that now. There we go. Okay. Good. And then let's look at this. Oh, we've got a lot for this one. This one's huge. Let's see if I can get it quickly. Okay, so here's the actual function that we're looking at. Let's just delete this. And we'll just include this definition as part of the doc string. Okay. All right. Complete the function called here we go, which takes a list as a parameter and returns the sorted version of the list, the reverse version of the list, the last element of the reverse version without removing it from the list. Okay. Looks like, okay, I'm just going to go off the doc string because that's a lot. It's a lot up there. All right, takes a list, list one, good. Let's write the function here. Call and unpack your function. Okay. So print, we'll pass it that X list. Okay. It looks like I'll need to unpack it, so we'll just test it for now and we'll unpack it in a second here. All right. Return the sorted version of the list. So we'll say return sorted. I'll do sorted list. I'm going to call this, oh no, I should keep it the same name because that actually might be important. We'll just do sorted list equals sorted list equals list one equals sorted list one. Reverse list, we'll just do this. The last element of the reversed list. So we'll do this. actually that'll be just the first element of the non-reversed list, without removing it from the list. Okay, so that just means give me the last element without using pop. Then, oops, is that actually, oh, yeah, that's fine. The number of times that the number 22 occurs in the list. So we'll say list.1 or list1 dot count 22. Let's just see if that's going to work. Comment that out, get some clearer output here. Okay, that looks good. That looks great. So what else did we want to do? We had to do an unpack or something. Sorted copy, reverse copy, last element, count 22. So my guess is that these are the variable names that we want to use for the unpack. So let's just do this. Equals that. And we'll just come in over here, comma, delete that. I think that'll be that. And then if I actually, oh, we got a parenthesis from there. Why don't I do this? Oops, no, that's not what I wanted to do. I wanted to do this. We'll print each one individually. Print, we should expect to see sorted, reversed, last element, which is actually just the first element, and the number of times 22 occurs in that order. Cool. Sorted 1, 2, 4, 4, 6, 7 looks good. Reverse 22, 88, 7. We have 22, 88, 7. And then number of times 22 occurs. We have, oops, 1, 2, 3, 4. Cool. Let's submit it. See what happens. Let's see what I had before. Oh, it looks like I didn't have anything. Good. All right. Cool. Well, that'll wrap it up. It's a little past 5:30, so or here in Mountain Time it is. Cool. Apologies about not being able to take those couple of questions. If you have like lingering curiosity as to why, or if you really want to like go through something, you're welcome to ask anything over a DM, and we can go in more depth in the DMs as well. Work things out further from there. Definitely feel free to hit me up on Slack for whatever reason. Let me know what you like and what you don't like about the study halls. I know it looks like my camera, I know it looks like I'm in like a completely pitch dark room here, but I don't know why the camera's not picking up the light in the room. But I guess it just gets a little darker outside, and maybe I just keep it dim enough. But to me, it's well lit. It's like normally lit in here. So I promise I'm not like a hermit or a mole person who lives underground. So yeah, we'll just put that to rest once and for all, hopefully. Okay, cool. I had a lot of fun. I hope you did too. I hope you found this engaging and educational. And I'd love to hear your thoughts. If you're on YouTube, if you're watching, well, of course, if you're not in the Galvanize pipeline, feel free to come and join us on Basic Prep. It's free for anybody to join. And once you get in our Slack channel, you'll be able to DM me and some of the other instructors, and we'll be able to help you start learning Python and data science. Like, comment, subscribe if you liked. and if you feel like commenting and subscribing, of course. And look forward to doing this again soon. We'll have a study hall normal schedule this coming week, Monday, Wednesday, and Friday next week. Cool. Awesome. Have a good rest of your day. Bye-bye.